This time, as we are on part 7 in this series, we just jump right to it. And what we are going to do, we are going to test the character EPROM to see if it contains some useful data for us. And we are going to do that just by pulling this ship. And this ship was a slight bit corroded, but the socket that it was in was actually has a lot of corrosion on it, and it actually breaks down when we try to clean it. So this socket is changed, and we are just going to pull the chip and try to read it in the mini programmer. And to read the EPROM, you just need to know its size, because all the ships of the same size has approximately the same pinout. And you need to be notified this is the one-time programmable proms and the UV proms with about the same designation, as this is 27C64 or C128. And all the manufacturers and all the part numbers that's almost like this, I'm almost certain that all of them have the same pinout for reading data out of the chip. And here I have chosen a generic 27C64A device in DIP28 sockets, and I've just unchecked the check ID mark to be able to read it out. And we are able to read out the contents of this ship, no error whatsoever. And in case we was able to read something back from this device, I am now going to save it as fast as I can to a 8K file on a local disk. And when we have saved the file, we can actually look into what we have been able to read out from this EPROM, and I must say this does not look good. It's FE over the whole area, so this is not a valid character PROM, that's for sure. And we try to read it again and we get the same result. So this is not good. But to make sure that we are not doing anything wrong here, I'm going to take off the label of the EPROM and check what's underneath. I just checked that this is not a thermo label, otherwise it will be brown when I try to use the heat gun to soften the glue. And even though this is not something I recommend trying, it is possible to erase EPROM like this with heat, if it's an UV EPROM at least. And some of the electrical erasable PROMs is also so that they will get unstable and can switch the bits when they are heated to a certain degree. Probably something about 100 degrees Celsius or something on the substrate, not on the outside. And while there are some glue left, ripping off the label is an easy task when it's heated, and here we can see that the chip in question is a microchip 27C64 with a 12.5 volt programming voltage, and this is a one-time programmable ROM chip, but that should not matter. But we try to read it out again anyway with the right configuration in the MiniPro programmer. And the first fault is that it can't read the ID right, and that's not promising. And on the second try we get the same data as before, FE in all the cells. So this chip is kaput. And all these chips are FF normally when they are new or blank, and when you try to burn the fuses they get to 1. At least in my experience is this like so, and in this case the least significant bit is stuck. At least that's the appearance. It could of course be something with the address counter. But as it appears to us, the least significant bit is stuck to 0 and the rest is 1. Yeah, I have to dig out some EPROMs. I have a lot of 2764 chips of different brands and manufacturers, and all of these are reused chips from back in the day. And there are some glue stuck on these windows, and if there is a lot of glue residue, I found that it might hinder them to erase, but often it doesn't matter at all. Here I break out my 30 years old. I actually bought this in 1992, so it's exactly 30 years old. And this is meant to erase 2 EPROMs at a time if you put them like so, but you can't put them so that the window is almost overlapping, and then you can take 3 into this slot and have them erased at the same time. And I don't think we need 3 chips to get this burned. I think we will only manage with 1. It's very seldom that I have trouble with these EPROMs. But the erase procedure takes about 15 minutes, I think. It's a timer on this. And I just connect this to 12 volt and push the button, and it's ready in 15 minutes. And just as you thought there would be no schematics in this video, we hit you with a piece of paper. As we saw in our last video, the picture was all garbled and you couldn't make out the writing on the screen, but you could make out that there was some attempt to draw characters. So that's why we took out the EPROM for the character set and tried to read it out and discovered that it was only F and E's in the whole chip. Not a good sign. And the chip that is used was actually not an UV erasable EPROM, it was a one-time programmable ROM. So we will not be able to use that again. And what other things can go wrong? Here you have the character EPROM and you have some jumper settings down here that say what chip this is, and on our device it's like this. The jumper JS6A is set, and that means that this is a 2764 EPROM. Otherwise it's possible to have a 27128 EPROM with double character sets, but that seems like it's not the case here, because this was a 2764 chip. And you also have the video memory, and the video memory that is used here is the 41464 chips, and this is the same chips that is used on the newer Commodore 64 with only 2 memory chips. So I have some of these in stock, and I will try to test these chips after I have burned a new EPROM with a character set. And as you probably also remembered from the last video, we did find a character ROM for this device, but that was not the Norwegian version, we think. Because this is a special EPROM, as we said here on the tape. This is a special one with characters for DK, Denmark and Norwegian in one chip, and that is to cover the special Norwegian AØ characters. But if we get this up and running with an international PROM, we will at least get something decent on the screen probably, and we'll have to reprogram the Norwegian signs later. And my PROMs on this is anyway UV erasable, so we have as many as temp as we like. And we also have the output buffers here, where we have an HC373 and we have an LS244 that stands as buffers in between. So we might have to check these buffers too. But this is my priority today. First this, then these two. Or maybe this and these buffers and then the video memory. So that's our take for today on this. The UV EPROM eraser has to stand for about 10 minutes, I think, before we get any result. They might be empty earlier, but there was some glue on the glass, so I think I will leave them on the full time. And yes, I did forget to tape this over, so I will put the tape on this, but I don't think it is erased yet. Otherwise, it's quite easy task to just burn this again. That's better than nothing, I think. And when we do look closer at this board, there actually are some signs that we have not done the cleaning or neutralizing of the acid good enough, or maybe gone overboard. Because here on these resistors and on this diode here, it's actually started to corrode a bit again. Some green has shown up here. And that actually might mean that we have to do the neutralizing bit again with vinegar and clear water, or if we have gone overboard and made this too much base, we might just have to rinse this out with some water. But this is not a good sign after all. And I still have not been able to find a good way to do the output of this. I do have this circuit here that plugs into my this is an adapter board that is meant to take analog video signals from VGA from 15 kilohertz video signals, that's both analog and digital, or baseband video, and output it to HDMI. And HDMI I do have capture devices for, and I made this plug here to plug into here to get the CGA signals to this adapter here. And I have used this once before. I don't remember if it was with a CBM Commodore 128 or something, but this time I was not able to get an output on this, so I had to use the original monitor. And the original monitor I just have to film straight off that, because I have no capturing device or something that I can see on that monitor. So this is something I do have to follow up on, because I do need to make sure that my fault finding procedures is not leading me astray as it might do with this kind of video conversion devices. So let's see now if our chips are finished cooking in the UV eraser, and see if we can get a good copy of a character ROM onto this board. To make sure all the EPROMs was erased, we do a quick blank check in the Mini Pro programmer, and as the same with reading chip, we don't have to change for the correct chip type, because this is checked with reading just the contents that it's FF. So all three these devices are blank, and I do think that this was a Signetics. I'm not sure about this, but both these are AMD devices, and I'm going to test these first. And both are 27C64s, and they do have some slightly abbreviations. This stands that it has 12.75 volt PGM. I've never encountered that exact for, but 12.5 is quite the normal thing. I'm going to test this one first, but first I'm going to find the file that we had last time. And I do have this file, but I do think I have to select the device first, and this was an AMD device, and it was a 24C64 without some letters behind, so maybe this one. This actually stands VPP 13 volts, but we are going to change that to 12.5, and I'm going to test my normal 5.5 here and verify like so, and we are going to browse for this file, and this one was the one I downloaded. So you can see that it does contain some stuff here, and we can try first with the check device and program. And it did actually went through, and that means that this device had the right kind of ID identifier on the device, 0x1015, but it did have other voltages than what was stated in this. So I've seen that a lot. We can take an extra verify. Yes, and that verify finished. So I think we can say that this probably is a good video ROM for the EuroPC. I'm just going to put a small tape over that. Yeah, just like so. All these old EPROMs here is recycled and has been used previously. I've pulled them out of devices. I bought some random kits with a lot of these recycled chips all through the ages. I do have some bent legs on this chip that makes it hard to put in the socket, but now I think I have nailed it, like so. Yeah, and that means I'm going to have to take a new test of the whole board with the CGA monitor to see if there is some difference from last time we tested this board. And power is on, and we hear some of the same beeps that we had last time, and after the long beep it will come some picture on the screen, and there it is. And this looks much better. This is readable signs. And I think this looks quite normal but a bit garbled. Let's freeze this picture. And of course, beware when I say normal, it's not in the normal sense of the word, but it's actually that I can make out that there should be something on the screen, and I almost can guess what stands here. So this is something we can work on, and I bet that this last sign is input for some date or BIOS or CMOS setting something. So this is clearly a good result. But clearly we have more work to do, so let's jump straight to the desoldering of the memory chips for the video circuit. And I do wonder if I'm going to take out the buffer chips at the same time. This is the memory chips. And if it's not the memory chips or the buffers here, we have a fault probably in the main video circuit chip, and that's not something we are going to swap, so then this board is dead. But I have high hopes in what we are doing here. We see progress from everything we make out and find out about this circuit. So let's first try with new memory chips. And of course we are going to test the old chips in the Retro Chip Tester Pro. And since there are almost no corrosion in this area, I'm going just to apply some fresh solder before I apply the desoldering gun. And then we are going to use hot air to make the chips drop out of the circuit. When I was working with this, and this is kind of a tedious work on these old boards, I decided to desolder the buffer chips and the latch chip for the video output also in the same operation. But to make sure that we are only fault finding on one fault at a time, I'm going just to reapply the old chips in new sockets and don't think about them. We just focus on the memory chips. But if you see the board, you will see that I actually has put those chips in sockets. Yeah, so here we can see the memory chips have fallen out of their home for the last 30 years, and we are ready to measure them out in the Retro Chip Tester Pro. But first I'm going to clean this board, first by using some flux and then by isopropanol, and clean out the soldering pads, and we are going to put in the sockets before we test the chips. And here we are using good quality socket with these round holes, and these are 18 pin sockets for these chips. And it's quite the difference from only 10 centimeters or 5 centimeters away on this board. This solder is flowing very easily, all the pads are just clean, and it's as I'm soldering a totally new board. Only one or two of the pads had some problems with making the solder flow, but when the flux melted, everything was okay. And I did manage to bridge two of the pads here, but I'm just using some desoldering wick and remove the excess solder. And here we are breaking out the Retro Chip Tester Pro, connected to 7.5 volt on the power supply, my lab bench power supply. And then we are just using this to test the memory chips, the video memory chips, the 41464s. And from before we know that we have to dim the overhead lights to be able to read the display. And we also know that the LEDs that indicate the power levels are okay is far too bright, so we have to dim them with a bit of white tape, and this actually seems to work fine. At least now we are able to read the display, so let's continue with the test of these chips. And as always, when there is some time ago that I've last fiddled with the Retro Chip Tester Pro, there are some pushing of the buttons to do before I'm familiar with all the choices and how the menu works. And on the Retro Chip Tester Pro, it's called the 4464, not the 41464, as is the neck designation. And you can see that it's organized at 64K by 4 bits. And now let's run the test at 5 times the speed, so that we can save some time watching this. Normally, if a chip is as bad as we saw on this display, it would have given a fault straight away, because there would have been fault with one of the bits or a large address area. And as you can see, now the test passed with flying colors on this chip. So now let's give the other one a try. And here is just to put in the chip and push the test again OK button. But here we can see straight away that something is wrong, because it asks us to insert 4464 chip. It can't even recognize the chip, and this is the normal way this reacts. If I had put in a memory card on this Retro Chip Tester Pro, it would have given me the opportunity to write the test content so far on this memory chip to a file on that storage. So clearly this chip is bad, so I'm going to a new chip out of my storage, and I do have some. I think those I have is 100 nanos, this is 120 nanos, but I don't think that matter much. But we are going to give that chip to a test in the Retro Chip Tester Pro before we put it in the EuroPC. And here is a brand new, never before used. It's a neck chip, these two, and it's a 41464-10, and that means that this is 100 nano and not 120 as the old chips. And as you can see, it passes the test with flying colors. So now we know that we have two working chips, one that was originally in this board and one brand new, and we are going to put these in our EuroPC. And after that we are going to give the EuroPC a new test to see if the situation with the garbled characters has changed. To reuse old chips that has been desoldered into sockets, you have to be careful so that you have removed as much solder as possible. But in these round sockets I find this quite easy. It's actually harder to fit the new chip than the old one in these sockets. But of course, every chip in a socket should be a tight fit, so that you are sure they make good contact. Yeah, so let's connect up everything again and give this a new test with the proper working video memory chips and see how this goes. And the power is on. I do think that the beeps sounds a bit different this time. And I also think that, yeah, this looks really promising. Look at the screen. This is quite extraordinary. I can read every character on this screen, and it's testing memory, and let's see how far it goes. It actually tested the whole 512 kilobyte of memory, and it actually was an option to run setup that was presented on the last lines. So this is certainly a result, and I'm very happy about this. But as I always get a lot of comments about this, we do have to try with the original keyboard controller. And as I stated before, this is not the real keyboard controller. This is a decoder for the built-in keyboard that delivers keyboard signals to the FE 2010 chipset. And I've plugged in this, and I took out the resistor that normally feeds the reset line manually. And we do try to see if we can hook this up and see what happens. And this is not a good sign. It does not seem like it will start. I did try now to push the reset button to see if we can provoke something. But I don't think this is anything real. I just think that's noise that happened. So I think I will try another hard reset with pulling the power and see if it gets stuck on no diagnostic codes again. And it is. So I do think we for certain can say that this controller chip is bad. And there is a recipe on the internet how you can burn another one, but I have checked my supply and I can't find this exact chip in my collection. So I will try to order one and see if we can fix it. But if not, this computer is never going to be as new again, because we can't use the built-in keyboard without this chip in place. But before I do anything with replacing the keyboard controller, I am actually going to try one more thing with this computer, and that will be the next installment in this series. I will try to hook up a PS2 keyboard or a DIN 5-pin keyboard to the FE2010 outputs and inputs for the keyboard to see if the keyboard functionality actually works. And I'm also going to hook up a battery to see if the real-time clock stores any information and that part of the circuit is okay. Because if none of these things are working, I'm not going to bother with taking another look at the keyboard matrix controller, as the other faults is too extensive to actually do anything about. And even though I have not hooked up a screen, you can see that this is booting exactly the same way as it did before. Now when I replaced the keyboard controller with the resistor again, that draws the reset lines to the right level. So that's it for this episode. I hope you enjoyed the content. Please hit like and subscribe. Share with your friends if you think they would like the content. And I do plan to make another installment in this series. And the first thing I'm going to do is to hook up a keyboard. I will hook up a battery to the real-time clock chip. And if these two experiments are successful, I will try to see if I can hook up an XT IDE in the slot to see if I can get this to boot something. But thanks for watching and hope to see you again in my next installment.